Hello. Um, all right, it's been a long day. Welcome back. Here are the instructions for part 2 of the PhET collisions activity. So by now, you should have finished part 1. And so part 2 is going to focus on the conservation of energy aspect of these collisions. And so you guys should already know what conservation of energy is. That was the unit before we went on the shelter in place and when the school was closed. So we're going to see if energy is conserved for elastic collisions and for inelastic collisions. And so just taking a look, you'll see that the data is actually exactly the same. And so if you wanted to do a shortcut, and you wanted to, actually that's a great idea, I should do that right now. If you wanted to do a shortcut and pull the data from what you did before, then you should be able to, not even have to launch the simulation, honestly. So I'm going to do that. All right. So let's pull some data. So for collision A, after the collision, if I go back and look, it went to a speed of 0. So I'll go ahead and plug 0 in. And it went to a speed of positive 4. And then I'll go ahead and do the next one for you. If I remember correctly, this became negative 4. And this one became positive 4. Go ahead and double check that. Oh, my memory served me correctly. Good. Let's go ahead and let's center these. Okay. So now you'll notice that what we're doing is we're going to calculate kinetic energy. And so if you remember the equation for kinetic energy, it's going to equal to 1/2 times mass times velocity squared. Okay. So let's go ahead and do that. So equals 1/2 times mass 1 times velocity squared. So 4 squared. 4 squared is 16. 16 times 1 is 16. 16 times 1/2 is 8. So this is going to equal to 8 joules. This guy has a speed of 0. So that means that it has 0 joules of kinetic energy. Okay. All right. For total energy. By the way, you'll remember that in the past we dealt with potential energy. You're not going to deal with potential energy in this case because there's no height. So what's our total energy? It's going to be 8 plus 0, and so that will equal to 8 joules. Straightforward. I just realized that these weren't merged. You can go ahead and you can merge those cells if you want. It's completely up to you. Okay. All right, now let's go over here. So same thing. It's going to be kinetic energy. Oops. Half. I'll just jump to the equation. Mass is 1. Okay, velocity is 0. Okay. Should equal to 0 joules. And right here, it's going to be, if you take a look, 1 and 4 again. And so we can just kind of jump to the answer. 8 joules. Okay. I'm going to go ahead and merge these cells. Okay. And this should come out to 8 joules as well. Okay. And so was energy conserved in this circumstance? Looks like it. Let's do the next one. So equals 1/2 m, it's going to be 3 times 4 squared. 4 squared is 16. 16 times 3. It's a little late at night for me to do that in my head. 48. Then 48 divided by 2 is equal to 24. Let's do the next one. So equals 1/2 3 times -4 squared. Hopefully you can kind of already see that it should be exactly the same. Okay. We'll go ahead and we'll merge these cells. 24 plus 24 is 48 joules. Okay. Numbers don't really change. It's 3 and -4 again, 3 and +4. So I'm going to go ahead and just kind of jump to the answer. It's going to be 24 joules again, and this is going to equal to 24 joules. Go ahead and merge these cells. Sorry that I didn't merge them for you like in the previous one. 24 and 24 is 48 joules. Okay. So is energy conserved? Looks like it. All right. So you guys are going to go ahead and you're going to complete this for all of the elastic collision. You're going to do it for the 50% elasticity, and then you're going to go ahead and do it for the 0% elasticity. And at the very end, you're going to answer the question of, does conservation of energy depend on the elasticity of the collision? Okay, you guys are going to answer a claim, evidence, reasoning statement for that, just like you did last time. Let me know if you have any questions, and be sure to show up to office hours if you're having a hard time collecting data for this. Again, you should be able to just look at your previous activity and just grab data from it. You should not have to open up the simulation again.